Hi students, welcome to my lectures. We are in the chapter of estimations of volume for a given pressure and temperature. We have so far covered liquids, equations of state. Now we are in the cubic equation of state. Ideal gas is covered, real gas equation through covered. And in the last lecture we have given an introduction about what exactly the cubic equation of state. In the present lecture we are going to take one simple example to find estimating the volumes using van der Waals equation of state. So every equation of state comes up with some assumptions, and when you compare with the ideal gas for the with respect to the van der Waals equation of state, the ideal gas assumptions are hypothetical gas and no molecular forces, intermolecular forces, and negligible volume of the molecules compared to the entire container volume. And if you try to use the ideal gas, less accurate predictions you are going to get if you do it for the, if you are trying to do it for the real gas. And the equation representing PV equal to RT. When you compare to the van der Waals, and it is predominantly is for the non-ideal or a real gas, considering the attraction forces between the molecules and the corrections for the molecules occupied by the gas in the container. So more accurate predictions you can able to expect. The equation that for the van der Waals cubic equation of state is P equal to RT by V minus B minus A by V square. So you can able to interchange the terms. This is also P plus A by V square into V minus B equal to RT. A, B are the constants which is specific for the gas molecule. For different gas molecules are there, the AB constants will be different because different attraction forces are going to present depending upon the kind of molecule you are dealing with. So first of all, let us use this particular, I have given some information about the pressure is in bar, volume is equal to centimeter cube per mole, gas constant centimeter cube mole by bar Kelvin, temperature is Kelvin, because we are going to predominantly this particular units for some examples. So I request you to keep this things remembering through the entire lecture series. So in order for me to estimate the volume, but what is the objective? Objective is to use the van der Waals equation of state and find out the volume, whether it could be liquid volume or vapor volume. So any volume you have to find out. To do that, you have to find out the constants A and B. So similarly, like the van der Waals, there are different other cubic equations of state. Every cubic equations of state comes with the different constants. So this constants account for the non-ideality of any molecules. So and it is said that there is a certain procedure if you follow to get the values of A and B. The A is 3 into PC VC square, B equal to half 1/3 VC. Okay, that means there is a specific procedure to get the informations about A and B, because it is because every molecule comes with a certain critical pressure and critical volume informations. Okay, because it is already available. So by using the available information, I can able to calculate A and B. Through this A and B, I can estimate the vapor volumes. VC, PC, everything are critical data. PC is the critical pressure, TC is the critical temperature, VC is the critical volume. Every molecule comes with certain critical properties. So these are registered and well known. So how I got this relationship? A equal to 3 times PC VC square and B is equal to 1/3 VC. So to get the information, I have to get the help of inflection point. If you remember our PV diagram, pressure volume diagram, liquid plus vapor and vapor. At a critical temperature, a line touches the axis, right, at a particular point. This is called the inflection point. Wherever the line meeting at this particular inflection point, this is a cubic equations of state. This cubic equations of state, which is a van der Waals equation of state at the present case, it is meeting at the inflection point. It has to meet these two conditions. One is derivative. Partial derivative of PC with respect to V. That means at critical pressure and critical volume at this critical temperature, dou PC by dou VC at TC equal to 0. That means the slope of this particular line will be equal to 0. Second, the slope of this slope is equal to 0. That means second derivative of the dou square Pc by dou Vc at Tc equal to 0. At this particular inflection point, these two conditions is going to met. Using these two conditions, we can able to get the information of A and B for the van der Waals equations. Once you get the A and B information, you can able to apply this van der Waals equation for any problem, any gas molecules or any molecule. So first of all, let us take at critical conditions, everything is Pc, Tc, Vc. So this van der Waals equations of state look like, if you take a first derivative at the constant temperature, that means while taking the derivative of this particular equation with respect to the volume, make the temperature constant, temperature Tc is a constant. That means if you take a derivative, if you see dou Pc by dou Vc at Tc equal to constant, because Tc is a constant, you don't need to take the derivative of the temperature here. So only thing that is derivable is volume here. So 1 by x minus 1 by x square. So derivative of 1 by x minus b minus example. There is some, imagine this is a constant. So we have to take derivative only with respect to volume because temperature is already constant. If you apply the first derivative, you are going to land up with this equation, and similarly you get some conditions. And if you take the second derivative of this particular equation, that means if you take one more derivative of this particular equation, you are going to land up with the second conditions. Using these conditions, if you do the mathematical operations, you are going to get the information about Vc is equal to 3 times B. Therefore, B equal to Vc by 3. You get one relationship. Similarly, if you do the mathematical equation, because every step is clearly mentioned here, step 3, from 2 you got information about this, and from different information 3 and 4 in 1, that means this is particular equation 3 and this is particular equation 4. In you are going to land up at different expressions. You are going to find out the information about Vc B equal to Vc by 3, one information, Pc equal to 1 by 27 into A by B square, second information, and using the informations you get A equal to 3 Pc into Vc square. Okay, if you try to solve yourself, because every step is properly provided, you don't need to worry about anything, simply you have to redo the things. So A is 3 times Pc into Vc square, B is nothing but Vc by 3, therefore you are going to get the information about the B. Already you got the Vc by 3. What is Zc? Similarly, if you evaluate compressibility factor at critical conditions, the Zc information, because sometimes Zc also equally important, Pc Vc by R into Tc. So if you do the mathematical operations, substitute the value of Pc and Vc, you do these operations, you are going to get Zc is equal to 0.375. So I have all the informations, A information, B information, Zc information. With all the informations, I can able to find out using van der Waals equation of state. Let us move forward. So I know A equal to 3 times Pc Vc and Zc equal to 3 by 8, B equal to Vc by 3. Okay, A equal to 27 R square Tc square by 64 Pc, and B is RTC by 8 Pc, because there are different expressions are there. I mean, already it is given this particular, using this mathematical operations, you can able to get the informations that how this equation has turned up. So let us use, there is an example, there is a certain molecules, substance is present at temperature, temperature 350 Kelvin and pressure is equal to 100 kilopascals or 1 bar. We are supposed to find out what is the molar volume of this particular substance. Before you attempt to use this particular equation, first of all you need to identify whether the volume you are going to get in this particular equation, right, what is, whether it's a vapor volume or a liquid volume. Okay, that is first step. Second step is find Pc, Vc, because these are the values, the critical temperatures, critical pressure and critical volume informations are already provided in the appendix B table 1 of Smith-Warner's book. Okay, once you get this A and B, because once you get the critical data, by substituting in this particular expressions, you can able to find A and B. Once you know A and B, you can able to use this particular equation to find out the volume, okay, or using van der Waals equations of state. I have already discussed about using phase identification lectures using a certain method, because one such a method is using Antoine equations. That means if you know the temperature, and you know the saturation pressure. If you know the saturation pressure, you know the temperature. That means saturation temperature and saturation pressure data can be estimated using Antoine equations. So to use the Antoine equations, which is estimated for the N-hexane, so in Appendix B and Table 2, and A, B, C informations for the Antoine equations are provided. So using that informations at 350 Kelvin, you are trying to find out what is the saturation pressure of the molecules. So the saturation pressure at 350 Kelvin is given as 1.3192 bar or 131.927. That means TSAT, PSAT, at saturation temperatures and saturation pressures of N-hexane I have identified. So using that information, let us identify the phase. So what given conditions are temperature equal to 350, pressure equal to 100 kilopascals. Okay, but the saturation conditions are 350 Kelvin and 131.927 kilopascal. So let us identify. Using the informations, TSAT is 350, PSAT is 131, but given conditions are 350 and 100. So the given pressure is lower than the saturation pressure as per the Antoine equations. That means there is a possibility that in this particular chamber, the N-hexane in the vapor form, because it is meeting this condition. When pressure is less than the saturation pressure at this particular temperature, then it is a vapor. That means whatever the volume which you are going to estimate using van der Waals equations of state, that means that is the vapor volume. So let us take N-hexane from the data TC value, PC value, VC value, it is already given in the tables. So using that TC, PC, VC values, we can able to estimate A and B values. Once you know the A and B values, let us use this particular equation. This equation is transformed to cubic equations of state if you do the mathematical operations. So it is in the form of AX cube plus BX square plus CX plus D. A is here X is nothing but volume, A is nothing but P, B is nothing but PB plus RT, C is nothing but A, D is nothing but minus AB. That means if you try to solve this particular equation, you get a 3 roots. All informations are already I have. I know temperature, I know A value, I know AB value. By simply putting all the equations, I used the calculator to solve. Finally, I got the information that I got only one real root by solving this particular equation. That real root volume is 29221.51 centimeter cube per mole. Okay, this is the molar volume of N-hexane which is in the vapor phase at this temperature 350 and pressure is 100 kilopascal. I hope now you have understood then how we can able to use the informations like saturation pressure and saturation temperature data to identify the vapor or a liquid once you get the data. So you can able to use the A and B. You can calculate the constants for the van der Waals equations of state. Thereby you can able to solve to get the information about molar volume of the N-hexane. Thank you. Let us meet with the new lecture.